So differentiation in simple terms is the process of finding the gradient function, or in other words commonly referred to as the derivative. When we differentiate, our aim is to find the gradient or the gradient function. So we obtain either dy by dx or y dash or f dash x. These are three different ways to represent the derivative by. So you need to realize that why we need to differentiate. We differentiate because let's say we have a quadratic function which results in a quadratic curve. So in this case, the derivative or the gradient at each and every point is different, and it can be it can be troublesome to find or determine a gradient at each and every point. So we come up with a common equation or a function which is referred to as dy by dx, and to find the gradient at any of these 4 points or infinite points rather, we only need the value of x, and by substituting the respective values of x we find the gradient. Therefore, by differentiating a quadratic or any equation which has a power of 2 or greater than 2, we find the gradient function and not the gradient. But if we differentiate a linear equation, we will get a gradient by differentiating simply, because the gradient of a linear equation is equal at all. Alright, so how exactly do we differentiate? For that, I'll cover this up model by model. So the first model is simple, that you need to bring down the power and subtract the power by 1. It's like a game. So dy by dx to represent the differential, bring the power down, reduce the power by 1. That's all we did. The first step is to bring the power down and then reduce the power by 1. Again here. So first step, bring the power down, reduce the power by 1, and this is my differential, 5x power 4. Similarly, in this case, dy by dx is 3, bring the power down, reduce the power by 1. 3 minus 1 is 2. So I'll directly write this down, no need to show the simple one. Now model 2. It's the same thing again, except for the fact that we are considering a coefficient this time with a variable, with a power. So we have a coefficient with a variable with a power. The concept remains the same in this case too. So we have dy by dx, bring the power down, so it gets multiplied with a, and reduce the power by 1. I'll change the color. So we had a as it is, I brought the power down, x n minus 1. Similarly, in example 1, dy by dx or y dash if you want to write it as that. So bring the power down, 12 multiplied by 8, and reduce the power by 1, so it becomes 7. And 12 multiplied by 8 is 96. So this is my derivative. For now, we cannot determine the exact gradient because we don't have an exact point to find it at. So we cannot find the exact gradient, but we did find a gradient function. So in example 2, it's the same concept again. Bring the power down to be multiplied with 7, reduce the power by 1. So it becomes 4. Thus, I have 35 x power 4 as my derivative or answer rather. So model 3 states that if I have a variable with the power 1, the derivative will be the coefficient simply. So it's dy by dx is equals to a. Now, I guess you guys should understand the background first. So how about we take an example? Let's say y is equals to 18x. I'll write this right. So in this case, realize that the power of x is 1. So when I bring 1 down, it's gonna be dy by dx is equals to 18 multiplied by 1 x 1 minus 1. So I have 18 x power 0, and x power 0 we all know is 1, and 18 into 1 is 18. So this is my derivative. So yeah, you can simply skip the steps and write down 18 simply. In these cases too, so y is equals to 5x. It's a linear, so dy by dx will simply be 5, and you know the background. Similarly, dy by dx, the differential of this 21x is 21, because 1 minus 1, and after bringing the 1 down, so you know the background, and it's gonna be 21. So model 4, again, it's the same concept. You need to realize that in this class, the models we are going to cover have the same concept. Bring the power down, reduce the power by 1. It's like a game, I repeat. So in this case, differential of a constant is always going to be 0. So since I have a constant here, it's going to be 0. That is, it's a flat line. Like y is equal to 5 is a flat line passing through 5 on the y. And why is this so? This is because, see, we have nothing here, so there's going to be a 1 here. 5 into 1, which I can write as 5x power 0. So, dy by dx is equals to 5, bring the power down, which is going to be 5 into 0, reduce the power by 1. So, 0 minus 1. And I have a 0 over a 0 into x minus 1. X minus 1 is going to go to the denominator, and it's eventually going to be 0. So no need to fall into the hassle of this background, and simply know that dy by dx of a constant is going to be 0. And then in this case too, dy by dx is going to be 0. dy by dx is going to be 0. And in the last two cases too, or rather in all these cases, dy by dx is going to be 0. Why so? I'll repeat, I'll write down the background. So let's say I have y 13, so there's going to be a 1 here. So y is equals to 13 x power 0, and dy by dx is going to be 13 into 0 x minus 1 after reducing the power, and this results to be 0. My differential is going to be 0, and that's the background. So the main idea of all 4 of these models was bring the power down, reduce the power by 1. That's all. So let's recap all these models with 3 examples. In the first example, dy by dx, we're finding the derivatives of all these. So bring the power down, so it becomes 4x reduce the power by 1. Similarly, minus, I have a minus 8 here, bring the power down, so it's gonna be multiplied with 3 and 3 minus 1. Similarly, 3, bring the power down, and x power 2 minus 1 plus 9, bring the power down, reduce the power by 1. And the differential of a constant is always 0. So. I have 4x cubed minus 24x squared plus 6x plus 9. So, just so you know, you can also skip the easy working. Do this all in your mind and simply arrive to the answer and you will get the marks. Similarly, in this case, I'll do it directly. So dy by dx, so it's 4x cubed, bring the power down, so it's gonna be minus 12 into 3, 36, reduce the power by 1. 7 into 2, 14, reduce the power by 1. 5 into 1, 5, reduce the power by 1, so it becomes x power 0, which is 1. And the differential of the constant is always going to be 0. No need to write that down. So this is my final derivative. My last and final example is this. So you might be a little worried that we have a square root here, but not to worry. The first step is rewriting the question. The square root is going to be rewritten as a fractional power. So I have x power half minus 6. And then simply find the derivative as it should be found. You can correspond the working. And then I have dy by dx, 3x square for this. 17 into 2 is 34. Reduce the power by 1. 3 into 1 is 3. And yep. And then I have this. So 4 multiplied by half x half minus 1, and the differential of a constant is 0. Thus, I have, just a second, and I can simplify this to eventually be left with 2x minus half. Minus half goes to the denominator and becomes a plus half, and I can rewrite this as this. Thus, this is my final derivative or answer. Before I end, always remember that the answer should always be left in the form the question is framed in. That is, the question had a square root, so I leave my answer with a square root. If the question had a fractional power, I'd leave it as a fractional power. That is the distinguishing quality of a distinction holder. And before I end, bring the power down, reduce the power by 1. That's Ace the Levels signing off.